Well, hello friend. I welcome you all in my channel Chemistry the Mystery of Molecule. I am Tanmay. So this is a continuation lecture of Pinacol Pinacolone. Actually, today we will discuss about the mechanism of Pinacol Pinacolone rearrangement. Mainly mechanism means focusing. Yesterday I have discussed about the preparation of Pinacol using magnesium and from ketone or aldehyde like that. I have explained the mechanism in details. I suggest you please see that video first. You can have an idea how Pinacol is prepared. And secondly, I have discussed many organic transformation which is essential or very important for student of 8+2 means 11-12, and for other higher study student it will be a recapitulation for you. Okay, so we will discuss about this Pinacol Pinacolone rearrangement. This topic is very important for every from 11-12 IIT-JEE NET to final CSIR-NET GATE. That thing, this concept is essential. And if for higher classes, if you don't understand this mechanism properly, you will not be able to answer the different problems. And in next video, I shall discuss about different problems which will be very useful for solving tough problem for CSIR-NET, GATE, JAM, etc. equivalent exams. Okay, so let's start. Actually, in this Pinacol Pinacolone rearrangement, you can see Pinacol means 1,2-diol is converted into corresponding ketone after a rearrangement. You can say rearrangement, and in presence of 3 molar concentrated sulfuric acid. Other methods are there also, but this is one of the most famous. So, and this distillation is essential to achieve this Pinacol. Why? Because this is a diol, means alcohol, glycol. So its boiling point is expected to be very higher due to hydrogen bonding, and you can say in product this is a ketone, no hydrogen bonding there. That's why its boiling point is relatively less. So that's why this distillation technique is utilized to purify this from this alcohol acid mixture. Okay, fine. So how this reaction happens? This reaction follows mainly 4 steps. One is protonation of Pinacol. Second is dehydration of protonated Pinacol and carbocation formation, and third is migration of alkyl or aryl group, means this substituent I have written methyl, it could be aryl also. So never get confused that only aliphatic undergo this. So again dehydration of Pinacol to produce Pinacol. So this 4 step. Okay, fine. And one thing you keep it in mind. Okay. So this OH has lone pairs and it can coordinate with the acid. And acid is actually here. This acid is sulfuric acid, means you can say H plus HSO4 minus. You may think that we sometimes read H plus 2H plus SO4 2 minus. Instead of that, why I am writing this? Because that is a dilution condition. Generally, in any solvent, sulfuric acid analysis this. If further cyanidation possible, then it will happen. And here, acid is acting as catalyst. Remember, because this is not participating in the reaction, but this is not changed ultimately after this reaction, but it is participating as a catalyst. Okay. So what happens? This proton will be protonated in presence of H plus, and what will produce? It will produce this. Why I have chosen this methyl example? Because it is the commonest and you have seen everywhere. So if you see the common term, it will be very easy to remember it. Otherwise, if I provide for aryl or R1 this thing, it is difficult to remember. So let's try for easy example. Understand the concept. In this way, you can attempt difficult problems. I believe it will be more helpful. So what happens? In presence of protonation, in presence of H plus from sulfuric acid, it will be protonated, or like this lone pair. So we can write this part in a different way also. We can write it this. Another thing right now, if you check, this OH is not a good leaving group, but this OH2 plus is a good leaving group, as after its elimination, it eliminates as a neutral molecule, water. So neutral molecule, and that's why this elimination is easier. I have explained this factor in the nature of leaving group during the substitution reaction. Please go through this if you want to have a complete clear idea about this leaving nature and contribution of this leaving capability or the after this protonation of this water molecule. Okay, if this leaves, it produces carbocation. Fine. So this is the first step, step number 1. This is the step number 2, that is dehydration and the carbocation formation. Now you can see this is a carbocation, and actually here it's a tertiary carbocation. So we can expect that this is stabilized through hyperconjugation. Please remember the effects. Please remember the effects responsible for the stabilization of reactive intermediate. Carbocation is a reactive intermediate, so it is stabilized by hyperconjugation. Here we can see 3 plus 3, 6 H are possible for this purpose. Fine. So what happens now? What could be possible? One thing that you can expect, this is a plus chart, this is a epoxide, oxygen has a lone pair, so it can form. And another thing, we know that it can form 3-member ring easily. It's true. It's true. Actually, epoxide is nothing but the dehydrated form of 1,2-diol. So, for example, there will be no permanent conclusion. Means if these also attached, then carbocationic charge will be on oxygen, so no conclusion. Even there are some examples which I explain in future video, that instead of 1,2-glycol you can use directly epoxide and protonate this for this carbocation generation. Then one thing you will miss, that is you will miss the water elimination step. Otherwise everything will be same. So this is not a means finally no effect it will be given. So it's possible but no effect. Another thing, it's a tertiary carbocation, attack of this is difficult due to bulkiness. Parallel to that there are another method. So I am saying not possible because there are other methods or other path available which is relatively easier or less drastic or less difficult. That's why this will not happen. But if in some XYZ reaction that other path is not possible, then this may happen. So never make a complete conclusion that this will happen or this will not happen. Chemistry is always flexible based on the circumstances and conditions. Okay, so fine. So what another thing possible, that it can push its lone pair and one of these alkyl group, both are same, can migrate. And with this migration is with this bond pair. Okay, so this is migration of this alkyl or aryl group based on the substitution. Here methyl, but if it is aryl, then aryl would have been migrated. But okay, fine. So after that, see, this oxygen pushes this lone pair to form a double bond. Another thing, it migrates to form this. This is actually, if you can say, this is protonated Pinacol. Okay, so this is nothing but protonated Pinacolone. This is nothing but protonated Pinacol. And another thing, you can see here, oxygen form 3 bond. Another thing, oxygen is attached to one hydrogen and double bond with this carbon. And oxygen's valency is 2. Generally it forms 2 bond, but it is attached to this hydrogen due to this step. But it will not like, because plus charge on oxygen. As we know, oxygen is a electronegative atom. It prefers to be electron rich instead of electron deficient, because plus sign means deficiency of electron, not addition of any positive charge or positron like that. It is a deficiency of electron, so it will not like. Consequently, what will do? It will pull back this bond pair and become a neutral oxygen. This is actually Pinacol. Okay, so this is the fourth step. This is the third step, and this is the fourth step. So important thing during this study is that this third step, and this is the most important step of this reaction. Here migration is happening. Okay, this migration from alkyl product. So when there is a chance of migration, then there will be a statement called migratory aptitude. What do I mean? Aptitude means tendency or capability for migration. For example, there are some two groups are given. For example, hydrogen and aryl, which will migrate more efficiently. And this efficiency is termed as migratory aptitude. Okay, and it is observed that this hydrogen migratory aptitude is more than phenyl, more than tertiary carbocation, second than this. So in this way, this is most efficient migratory aptitude hydrogen, and least is according to this list carbon. Fine. Please try to keep it in mind. It will be helpful. And actually, the TS look like this. Because TS means the bond involved during the bonds broken or produced, or more specifically if we say bonds involved in the transition state. So this bond is breaking and another bond from this and this is forming one part. Second, that another bond is forming between this carbon and oxygen. So this is involved. So see, this blue color is the bond involved in the transition state. So this is, and actually this is a carbocation produced. So this delta positive charge is on this oxygen, delta positive, this carbon, this. So overall you can see in transition state is actually it is overall a positive charge and it's cationic in nature. Consequently, two factor plays role. One is the electron richness of this, or how this R group can hold positive charge. Capability to hold positive charge. Capability to hold positive charge. And second is bulkness. So first point is this and the second point is bulkness. So these two factors determines which one is a good leaving group and which one is not. So if you see hydrogen is getting advantage from bulkness factor, very small, so easily can migrate. Fine. Phenyl getting advantage because of electron rich nature. Because we know this phenyl is this, and if this is phenyl, for example, it may have in this way positive charge, means this two. One is this is. So one carbon, this is two carbon. So in this way positive charge is localized. So from charge point of view it is stabilized. And for phenyl, there is a chance to delocalize this charge through resonance. But in case of this tertiary, secondary and primary, option is through plus I effect. So, and we know that resonance is more powerful than plus I effect. And another thing, tertiary is bulkier also. Secondary is also significantly bulkier. So that's why a combination of all these factors resulted in migratory aptitude, where in this direction migratory aptitude decreases. So this is the overall understanding about this Pinacol Pinacolone rearrangement. And another thing, as I told, these undergo through a carbocation formation, and we know the carbocation has a tendency to form more stable carbocation, and this factor is supported or proved by this migration of this alkyl group. Okay, so all the factors is support I have explained in this video. I believe it will be, I believe you have understood for this, and it will be useful for your study and exam. So if you like my teaching, please give a like, share this video among your friends such that many people could be benefited, and subscribe my channel Chemistry the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload. So before ending the session, I want to announce you that in the next video I will explain about the examples. Okay, so please see. And for +2 student, means high school student, I believe this much amount is enough for your understanding. Next example will be difficult, so not useful that much for you. So see you in my next video.